In July of 2025, a telescope in Chile spotted something moving too fast to belong to our solar system. It was a frozen mountain older than the sun itself, and once it leaves, it will never, ever come back. Astronomers called it Three Eye Atlas, only the third confirmed visitor from interstellar space that humanity has ever caught passing through. Within weeks, its chemistry started breaking rules that every comet in our solar system has always obeyed. But first, the chase. The Atlas Survey Telescope in Rio Hurtado, Chile, flagged it on July 1st, part of a network built to defend Earth. The giveaway was its path, a hyperbolic orbit, a trajectory so stretched that the sun's gravity could never hold on to it. Its eccentricity measured over 6. Anything above 1 means escape. This object was not orbiting the sun, it was passing by. Digging through archives, astronomers found it lurking in images from early May, nearly 2 months before anyone noticed it moving. Only 2 visitors came before it. Oumuamua, the strange elongated rock of 2017, and the comet Borisov 2 years later. But those 2 were appetizers. This one was bigger, brighter, and about to be studied by the most powerful telescopes ever built. When the James Webb Space Telescope turned toward the comet, it found a cloud of gas that made no sense. The coma was drowning in carbon dioxide, roughly 7 times more, relative to water, than a typical comet ever shows. Alongside it came carbon monoxide, methane, cyanides, sulfides, and water ice. And then something stranger. Atoms of pure metal, floating free. Telescopes in Chile detected nickel glowing in the coma. Nickel usually appears with iron. Here, at first, the iron was missing. Metals should only vaporize near a star's furnace heat. This comet was out in the cold. Something else was freeing that nickel. One suspect is nickel tetracarbonyl, a fragile industrial molecule that shatters in sunlight, releasing metal atoms at surprisingly gentle temperatures. If that is right, the comet carries a chemistry we normally associate with factories on Earth, forged instead around another star entirely. As it neared the sun, iron finally appeared too, and the strange nickel readings drifted back towards something more familiar. Low ammonia, towering carbon dioxide, free metals. No object born in our solar system has ever shown this exact fingerprint. So where was it born? The answer was dissolved in its water, and it pointed somewhere almost unimaginably far back in time. Every molecule of water carries a signature. The ratio of ordinary hydrogen to its heavier twin, an isotope called deuterium. In 3-hour Atlas, deuterium levels came out near 1%, more than 10 times higher than any comet we know. Carbon isotopes told the same story. Ratios beyond anything measured in our solar system, our nearby clouds, or planet-forming disks. Chemistry that extreme only forms in extraordinary cold, around 30 degrees above absolute zero, in an environment starved of heavy elements. That points to the outer disk of an old metal-poor star, a sun that formed when the galaxy was young. Tracing its motion through the Milky Way suggests an age between 3 and 11 billion years, possibly the oldest interstellar object we have ever found. Some analyses stretch further, suggesting the comet may have formed nearly 12 billion years ago, when the universe was a teenager. Our sun is 4.6 billion years old. This visitor may have been drifting through space for twice that long. Something, long ago, threw it out. Most likely a close brush with a giant planet or a passing neighboring star. Then, as it swung around our sun, it did something comets are not supposed to do. It moved off course. Radio telescope measurements taken near its closest approach found the comet sitting slightly away from where gravity alone said it should be. A famous Harvard astronomer, Avi Loeb, had been keeping a public list of anomalies, and the internet ran with it. Speculation exploded. A probe, a Trojan horse, a propulsion system. Conspiracy theories swirled while the comet stayed silent and kept moving. Scientists had a duller, better explanation. Jets, escaping gas and dust, act like tiny thrusters, gently nudging an active comet's path. This happens to ordinary comets all the time. The question was whether 3I Atlas was venting enough gas to explain it. An international planetary defense network tracked it for 2 months straight, from late November through January, measuring every flicker of brightness. NASA's verdict: the perturbations were small and fully compatible with ordinary outgassing. No engines required. No aliens, just ice doing physics. The comet even seemed to vent from spiraling jets, and some researchers saw hints of ice volcanoes erupting across its surface. Webb measured it shedding roughly 150 kilograms of material every second as sunlight tore into its ancient ices. Losing mass that fast near a star is how comets die. The real question was whether it would survive at all. On October 29th, 2025, it reached perihelion, sweeping within about 200 million kilometers of our sun. At that moment, it was traveling 68 kilometers every second, about 153,000 miles per hour, its maximum speed. Smaller interstellar comets might have crumbled. Borisov's nucleus partially fragmented. Everyone waited to see what would emerge from behind the sun. It emerged intact. Hubble later separated the nucleus from its glowing coma and sized it near 2.6 kilometers across. That makes it far larger than Borisov, a genuine mountain of primordial ice, toughened by billions of years in deep space. In December, Webb added one more discovery: methane, a hypervolatile ice that only survives if a comet stays profoundly cold. On December 19th, it made its closest pass of Earth, a comfortable 270 million kilometers, nearly twice our distance from the Sun. Amateur telescopes could still catch it through spring. Then came the goodbye, and the goodbye carried a strange promise. On March 16th, 2026, it brushed past Jupiter at 54 million kilometers, its final planetary encounter in our system. By the early 2030s, it will exit our planetary neighborhood forever, carrying its 12 billion year story back into the dark. So, what did a few months with this visitor actually teach?